Here we're given a secondary bromide substrate, and secondary substrates can undergo any of the mechanisms: SN1, SN2, E1, E2. Our nucleophile or base is sodium hydroxide. That's a strong nucleophile and a strong base. So that is going to have a preference for SN2 and E2. And then heat favors elimination. So elimination could be E1 or E2. Now if we compare all of these things, our common feature is the E2 elimination, so that's going to be the operative mechanism here. Here we have a molecule with some stereochemistry to consider, and remember that the beta hydrogen and the leaving group, in this case the bromine, must be anti-periplanar. So what we need to do is rotate around these carbons, or around this bond, to get, in this case we're going to eliminate from this beta hydrogen. So I'll go ahead and draw that in on the wedge, and this bromine. Let's go ahead, just keep our stereochemistry straight, drawing this hydrogen on a dash. So now what we want to do is get these groups anti-periplanar. So let's take this one step at a time, and first I'm going to rotate around this carbon, and I'll rotate the hydrogen down into the plane, this propyl group back, and the methyl group out. This carbon will stay the same. So I still have my bromine out, hydrogen back here, but now I've rotated the hydrogen down, the methyl group out, and this propyl group back. So I have the hydrogen in the plane, but I need the bromine anti to that hydrogen in the plane. So I'm going to rotate around this carbon just enough to push this bromine back into the plane. So that I get this nice anti-periplanar arrangement of the H and the Br. Still my methyl, my propyl group back, but if I push this bromine back into the plane, that pops this methyl out, and then this hydrogen stays back, but it just kind of pushes it further around to the back. Okay, from here, we can do our elimination using our base hydroxide. The H and the Br are lined up anti-periplanar. We'll eliminate. We get our alkene. Now we can use our relative stereochemistry here to figure out the stereochemistry of the double bond. So on my left carbon, I have a methyl out. On my right carbon, I have a methyl out. So these methyls will end up on the same side of the double bond. Here's the left methyl and the right methyl that were both out. And then On the left carbon, I have this propyl group back and hydrogen back. So on my left carbon, here's the propyl group. On my right carbon, here's the hydrogen. But since that propyl and hydrogen were both pointed back, they end up on the same side of the double bond. So this is my E2 product, and it is a result of Zaitsev elimination because I got the most substituted double bond possible.